Hello, welcome back. So we'll be dealing with kind of difficult exponential equation. So what we are expected to find is to find x. So how do we find x? Solution. So we have 16 raised per x plus 20 raised per x equals to 25 raised per x. Let's divide both sides by 25 raised per x. So when you do that, we are going to have this. So we have 25 raised per x on the right too. So we are going to apply one property here. Whenever we have something of this form, let's say we have a raised power n over b raised power n, is simply the same thing as writing a raised power n over b raised power n. So this is the property we're going to use. So we have 16 over 25 raised power x plus 20 over 25 raised power x. But this guy, they are the same, so we have 25 raised power x equals 25 raised power x. So let's go further. 16 can be written as 4 square. Likewise, 25 as 5 square. Everything raised by x plus 20 can be written as 4 times 5. 25 as 5 times 5 raised by x equals to 1. So in this case, let's pull out 2 the power. So we have 4 over 5 raised by x times 2. I just switch this x and 2 plus, in this case, 5 cancels 5 here. So we are left with 4 over 5 raised by x equals to 1. So now, let's suppose we let p to be equals 4 over 5 raised by x. So anywhere we see 4 over 5 raised by x, we just replace this by p. So we have p squared, we plug it here, plus p equals to 1. So now, this is a quadratic expression. So we have p squared plus p minus 1 equals to 0. When this guy comes to the left, so this guy is not easily factorizable. We can use quadratic formula to solve it. So we call that p equals to minus b plus or minus this plus or minus square root of b squared minus 4ac over 2a. So now the coefficient of p squared is 1. That is a equals to 1. And for here we have b to be equals 1 and c equals to minus 1, which is the constant. So let's plug in these values here. So we have p to be equals, what is b1? So we have minus 1 plus or minus square root of b squared as 1 minus 4 times 1 times minus 1. Everything over 2 times 1. So we have minus 1 plus or minus, this is 1 minus 4 times 1 times minus 4, that gives plus 4. Everything over 2. So we have minus 1 plus or minus square root of 5 over 2. So p is either equals to minus 1 plus square root of 5 over 2 or minus 1 minus square root of 5 over 2. But you will observe that this is a complex root, that is minus 1 minus root 5. So we are going to ignore this. So we are going to consider the positive case, that is when p equals to minus 1 plus square root of 5 over 2. So we are going to plug it here. So since p equals, p equals 4 over 5 raised by x. So now we replace p here. So we have minus 1 plus square root of 5 over 2 equals 4 over 5, everything raised by x. So let's just put this in bracket. So now we take the natural logarithm of both sides. So we have log minus 1 plus square root of 5 over 2 equals log 4 over 5 raised by x. But recall that by rules of logarithm, whenever we have log a raised by b, is simply the same thing as b log a. So we are going to apply this property here. So we have, let's just switch this. So we have log 4 over 5 raised by x equals to log minus 1 plus square root of 5 over 2. So we are going to apply this property. So now we have x log 4 over 5 equals log minus 1 plus root 5 over 2. When we divide through by log 4 over 5, so we have x on the left, x equals, sorry for that, x equals log minus 1 plus root 5 over 2, everything over log 4 over 5. So that is the solution that is required. That's it. Thanks for watching.